The objective of this tutorial is to demonstrate how to fabricate hook electrodes for obtaining extracellular recordings, such as these, from nerves and muscle fibers, and how to use them in an experiment. I'll provide an overview now. Hook electrodes are composed of a twisted pair of stainless steel wires. The wires are coated by the manufacturer in a thin insulating layer of enamel. To hold the wires together, we can coat them in common household silicone glue. Each wire must be de-insulated at both ends by scraping away the enamel. On one end, each wire will have a gold connector pin soldered to it, allowing it to be plugged into a cable that feeds into an amplifier. On the other end, one wire in the pair will serve as the recording electrode. It will be shaped into a hook and can later be attached to a nerve or muscle fiber. The second wire serves as a voltage reference. It will rest in the surrounding fluid, a short distance away from the nerve or muscle. A differential amplifier will boost the voltage difference between the two wires, allowing microvolt scale signals produced by neurons to be recorded. To pick up signals from the target tissue, the hook needs to be in direct contact with the nerve or muscle. The hook must also be electrically isolated from the surrounding fluid and from the reference wire. Surprisingly, ordinary superglue can do the job, as it is an excellent electrical insulator and just needs to cover the exposed wire of the hook. This is the fine stainless steel wire that we use for making hook electrodes. It's only 1/1000th of an inch thick, or about 25 microns. Here I have a spool of the wire mounted on this pull, which also has this homemade contraption. I have here a hand-operated battery-powered motor. I can press this button to rotate that little clip. There's this horizontal bar here and another above. I'm going to tie a rubber band to the top of this. I want to make sure that I take a segment of the spool that hasn't been yanked on or kinked in any way, so I'm going to cut off the bit that's here so that I can make sure I have a new segment. To get started, to one end of this wire I'm going to attach a small piece of tape. I can fold the tape over on the wire, and because it's so tiny, it can still pretty easily slip out of that tape. But it stays better if I rub it in really well with some hard object, like the end of these forceps. Now I'm going to take the end of the wire and pass it through the rubber band at the top and bring it down. My goal here is to create two parallel strands. Passes through the rubber band, and the other end will need to be held at the clip on the motor. So I'm going to use a little bit of tape to secure these together. I want to make sure the two strands meet together, that there isn't a gap between the two. And then I'm going to fold this over. Now I can cut the excess wire off. And I have simply a loop that passes through the rubber band at the top and is joined at the bottom by tape. Now I want to hold this with the alligator clip here that's mounted to this motor. The rubber band gives me a little extra stretch, so I can almost reach that, but I actually cut it a little bit shorter than I would have preferred. So I'm going to elevate the motor to meet that, and I can do that by changing some of these clamps down here. Okay, now that this is lifted up, I can grab the tape with the alligator clip. And so now I'm just going to give this a few pulses in order to twist the two strands together a few times. It doesn't have to be a whole lot. Probably ran that for a total of 5 seconds at most. If I run my fingers over the twisted wires together, I can kind of try to distribute the turns throughout the entire length. Otherwise, they tend to bunch up in the middle. And now I've got it to the point where I can see the wires are twisted together all the way down to this point at least. And at the top, there's a similar small gap near the rubber band right here. And that is fine. That also tells me, because that gap is pretty small, that I've twisted this enough. And so now I want to transfer this tape off of the clip and secure it to this bar. This is some standard bathroom silicone glue, which is used for waterproofing normally, but we're going to use it just to hold together these two twisted strands to form an electrode. The best way to apply this glue is using your own fingers, because then you have the most control. I prefer to do this with a gloved hand, though you might find it easier to do without gloves. I'm going to get a small bead of this glue between my index finger and thumb. And then I'm just going to run my hand down the length of the electrode, trying to apply the glue evenly and thinly. If you get clumps, you can usually spread those out. This glue gives the electrode strength in addition to holding it together. But the thinner the coating is, the lighter weight the electrode will be, and it can be attached to nerves without yanking on them. So now I just need to let the glue dry, and then we'll be on to the next step. After the glue has dried, I've cut my electrodes off of the drying rack, and I have this long pair of twisted wires covered in glue. I'm going to cut this in half so that I can get 2 electrodes out of it about this length. The next step is to remove the glue from each end of the electrode, exposing the wires again. To do this, I like to tape down both ends of the wire so that they're visible under the microscope. And using forceps, I should be able to strip the glue off of the wire. With my non-dominant finger, I'm able to press down hard on the electrode behind the point where I'm pulling in order to stabilize it and prevent it from shifting out from under the tape. Now that I have one side exposed, I'll do the other. This step of removing the glue is much, much more difficult if you pressed hard while applying the glue, which causes it to make too good of contact with the wire, bonding really well to it. If instead you did just one quick pass over the wire very gently with no pressure at all when applying the glue, it tends to stick much more to itself than to the wire, and it strips off easily like this. Now that the silicone glue is removed, I also need to strip away the insulating enamel that covers the stainless steel underneath. so that I can expose the conductive steel and move on to the next step. For this, I'm going to use a pair of fine forceps to very gently scrape away at the enamel, which will flake off. Under the right lighting conditions, it's possible to see a little bit of color on the wire. It'll have a sort of goldish tint when the enamel is there, and then when stripped away it will look silvery like steel. So again, it's important to apply some pressure with my other finger to stabilize the wire, and then very gently try to scrape along the length of the wire. Okay, already there you can see some of the enamel is flaking off right here. It can also be very helpful to be mindful of the direction in which you're scraping. If you scrape in a straight line parallel to the wire, it will remain straight. If you twist the forceps a little bit like this while you're scraping, you're going to induce a curl in the wire, which can be annoying to work with. As you can see, if I press down, if I squeeze them tightly, they separate at the end, and their surface of contact is further back. So I'm going to try to make sure I use that. And that's certainly working better. Harder to control, but I'm able to make contact that way. So now you can see the enamel flaking off like a banana peel. And the color of the wire underneath is silvery, whereas the thing coming off is a gold color. I've exposed enough wire there to be able to do the tests that I want to do next. So I'm going to move on to another wire and complete this for all 4 wires. If while you're doing this you don't press hard enough with your other hand, the wire may start to slide out of the glue, and then you'll get some sort of like kinks further down in your electrode. There, you can see that one was much easier now that I was using the right part of this somewhat bent tool. Onto the other side. Sometimes you can even get away with scraping both wires together, like this. It's not uncommon to break the wires during this process also, in which case you may have to trim back more glue and start again. Sometimes I find that scraping 2 wires at once distributes the force a little more safely, and they're less likely to break. And here I've managed to strip away the enamel from both simultaneously. So now that I have all 4 wires exposed, I'm going to kind of fan out the wires so that I'll be able to do a test for continuity more easily. It helps to be able to see all 4 wires at once under the microscope for this next step. So next, to make sure that everything's working fine, I'm going to use this multimeter. If you set it to this mode, which is just for checking continuity of electrical conductors, you'll be able to see if the wires have any breaks in them and ensure that you don't have any shorts. So if I just power it on, make sure this is turned to the continuity checker, what you'll see if you take the 2 probes and touch them to one another is, for one thing, you'll get a noise. And also the display will change from simply saying 1 to some number indicating the resistance of the connection. And if you're touching 2 large probes like this to one another, it's basically going to drop down to 0. Here we're going to be working with these very fine wires, and the resistance will probably be on the order of 100 or a few hundred. So that number will be displayed, and it actually won't make the beeping noise because the resistance will be too high for the sensor to decide to beep. But nevertheless, it's still useful to see those numbers. What I'm going to do now is place this on the table so that I'll be able to see the display in my peripheral vision as I'm looking through the microscope. And I'm going to use these probes to touch the wires and check for continuity. And my signal that I've succeeded will be seeing this display change to some other number during the process. So since these are two twisted pairs of wires, it should be the case that one of the wires on the left connects to one of the wires on the right, and same for the other pair of wires. I don't know which is which. Could be these two go together or these two go together. But what I want to make sure is that there is in fact a partner on this side to that wire, and that there's a partner to this wire on this side, and that I don't have a short, meaning that both ends here are continuous with this wire over here. That could happen because there's some damage to the enamel but not the wire itself somewhere along the length of the electrode, resulting in the two wires touching each other. And of course, if I don't have any connection, that could be because the wires were damaged at some point. So here it really helps to have this taped down on a wooden surface, because the soft wood kind of conforms to these probes in a nice way so that you can press hard and make good contact but not damage the wire. So here I'm pressing down on the left, and I'm going to try to touch this to the wires on the right, while at the same time using my peripheral vision to see what's going on with the multimeter. Okay, right there I see the number 308 on the display, indicating there's 308 ohms between these 2 points. And that tells me the leftmost and rightmost wires are continuous with one another. I want to verify that this one is also not continuous. And as I'm doing this, I'm getting nothing. The display is not changing. So that's good. And now I want to check that this wire does go to its partner here. And sure enough it does, 308. And just to make sure, I'm going to check this as well. And nothing. So that's good. That tells me that my twisted pairs are in good shape. So now the next step is to use the soldering iron to attach gold pins to one end of our electrode. 2 gold pins will be attached to 2 wires adjacent to one another on one end. And so the way this soldering iron works is there's a power switch on the back, and then this button here will turn on the iron. As soon as I press this, this is going to begin to heat up, and it's going to get up to several hundred degrees, so it's very important that you don't touch it while it's hot. Additionally, there is here a smoke absorber, which I recommend turning on, that causes a vacuum to be turned on here, which will absorb any vapors that come off of the solder as you're using it. But I think before I actually begin using this, I'm just going to keep it off and finish setup over here. It's best not to leave this heated for an extended period of time, because that will over time damage the tip of the iron. It heats up very quickly. Perhaps within 30 seconds it's warm enough to use. So there's no sense in leaving it on for 20 minutes while you do something else, like you're preheating an oven. Here I have a manipulator that's going to hold the gold pin I need for me during the soldering process. This is just an alligator clip mounted on a heavy weight, and here you can see I've got the gold pin held in place. Okay, here you can see the gold pin under the microscope, and at this end you'll see what's called a solder cup. I'm going to fill it first with some solder, and then I will reheat it and insert the wire. We have both leaded solder, which contains lead, and lead-free solder. Leaded solder has a lower melting point, so it's easier to use, but of course it's toxic, and both of these will put off some fumes as you're working with it. So that's why it's helpful to use the smoke absorber. But if you're concerned about adverse health effects, you can try the lead-free solder, and it's not that much more difficult to use. First I'm going to cut off a chunk of solder, just using a razor blade here, but you could probably even break it off with your fingers. I like to be able to hold a chunk about this size. I then also want to wet this sponge so that I can occasionally wipe off the soldering iron to keep it clean. And so I want to have this sponge a little bit damp. And now I'm going to turn on the heat as well as the smoke absorber and give that a minute or so to heat up. Here you can see the temperature climbing. So at this point this is very hot. This whole iron here is very hot. It's only at the very end though where we're going to apply the solder. You can see the end is somewhat shiny. The rest of this is actually quite corroded at this point because this isn't a very new iron. In order to conduct heat, it's really important that the end is shiny. So if it's brown or black or corroded in any way, that will make it very difficult to transfer heat to the solder or to the gold pin, and so it's not going to work very well. What you can do is use this material here, this brassy material, as sort of a scraper when you're done with it in this way, in order to kind of brush it clean. You can also do a little bit of this sort of action on the damp sponge, though I still recommend doing this at the end so that there isn't any sponge or scraps left behind. Right now I have the tip looking very clean but not especially shiny, so what I need to do to kind of prime it is to just put a little bit of solder onto the end of this, and you'll see that instantly it should melt. And some of it is adhering to the end of the iron, and that will act as an excellent heat conductor as I'm applying solder to this gold pin. I can brush a little bit of it off here, and now what I'm going to do is apply heat directly to the gold pin by pressing on the underside of the gold pin, giving it a moment to heat up, and then I'm just going to slide this solder into the solder cup, filling it up See, it melts instantly. And then I can take away the iron, and it should solidify. I'm going to clean this off again using the brass wire here and set it down. I want to do one more gold pin in this way, fill up the solder cup. So I'm going to set this gold pin aside and grab a second and mount it on the clip. And again, I might not need to do this, but I'm going to apply a little bit of solder to make sure it's really conductive of heat. Touch the underside of the gold pin, give it a moment to heat up, and then slide the solder in, and then take away the heat and the solder. You'll see that there's this fluid that kind of comes out with the metallic solder. That is the flux, which just helps the solder flow a little bit, and that's okay. You can just leave that there. So I'm actually done with this for a moment because I'm going to want to spend a little time with setup. So I think I'm going to actually turn off the heat. Before attaching the gold pins, I would like to expose more of the wire. Not by removing the enamel, but just by stripping back more of the glue, probably on this side, so that I have perhaps a total of 1.5 centimeters or so of wire exposed. And that's going to allow me to separate my gold pins in the final stage when I'm taping them together. Again, I can put my fingernail down behind where I want to go and try to grab the glue. Sometimes you can use a razor blade in order to get the initial cut started, like this. Of course, being careful to avoid the wires. I think I want to take off even a little more. And this next step will require some dexterity with both hands, at least the way I'm doing it. Perhaps by reconfiguring your setup, you could do it a little differently. My plan is to, with one hand, my non-dominant hand, in my case is my right hand because I'm left-handed, I'm going to apply the heat to the pin and remelt the solder. And while it's still liquid, I'm going to, with my dominant hand holding, using the forceps, pick up the wire, one of the two wires, and insert it into the liquid solder, and then remove the heat. And as it solidifies, or once it's solidified, let go of the wire and it should adhere and stay inside. The solder itself will have some surface tension while liquid, just like water. And because these wires are so small and delicate, it can actually be difficult to slide the wire in and pierce that surface tension. Instead, it might be deflected by the surface tension. So it helps to make sure that your positioning is good ahead of time, such that you'll be able to push the wire directly into the solder, perpendicular to its surface. Now I have the end of the electrode taped back down to my block of wood with the gold pin positioned just above it. That'll make it easier for me to manipulate the wire into position. With my left hand ready, I'm going to take the iron and tin the tip by applying some solder to the end of it, and then brush that off. And now I can apply heat directly to the pin. Insert the wire. Remove the heat. And now the wire should be held in place. I need to be careful at this point that I don't move the block relative to the clip, or else I might tear the wire. But I'm going to give this a gentle tug just to make sure it's in place. It seems to be. So now I can release the pin and do the second one. So now I'm going to tin the tip, brush it off, heat the pin, melt the solder, insert the wire, remove the heat, and verify that the wire is in fact in place. And I can now shut off the iron. But I do want to make sure that I put it back in a cleaned state. So that means brush it off a little bit using the sponge if it seems like there's stuff on it. I'm going to tin the tip once more, brush it off here, and now it's looking clean and shiny, ready for the next person. I'm now going to repeat what I did before. I'm going to check for continuity to make sure that I have not damaged anything in this process and that my soldered connections are actually working. So again, I have taped everything in place, and I'm going to use the multimeter to check for continuity. Nothing there. There. Okay, those are continuous. And these are not. Switch wires. That is working as well. 310 ohms. And those are not continuous. So everything is okay. Next, I want to tape these two pins together in order to strengthen the electrode and have a nice handle to hold on to when I'm using the electrodes in the future. So you could choose any color tape for this. If you have multiple electrodes, it certainly helps to use different colors of tape. That way you can distinguish one electrode from another. And I'm going to lay down the tape sticky side up. And place my pins carefully like this, so that this wide part here is just at the top of the tape, and I want the pins to be parallel and about a centimeter or a little less apart. I also want to make sure that on this end I bring the glue up inside of the what will be the wrapped tape. That way it all holds together and I don't have these very delicate wires here acting as load-bearing points on the outside of the tape. I can kind of just press those in a little bit. And now I can fold the tape onto itself gently, trying to line it up nicely so that I don't have sticky parts sticking out. I also like to make sure that I press tightly in between the pins and around them so that they really aren't going to move very easily. I want it to be nice and tight like that on both sides of the pins. If they move much, in the future during insertion into a cable or removal from a cable, of course those solder joints might be damaged. Just to strengthen this a little more, I'm going to add one more layer of tape wrapped around the whole thing. There we go. So again, at the base, you can see the glue is there to support it. And our pins are looking good. So now I need to shape one of the two wires at the other end of the electrode into a hook and the other into a reference wire. So again, I want to tape everything in place. So the idea here is one of these two wires should be shaped into a hook, or a J shape, where the size of that curvature of the J is about 1 millimeter in diameter across the semicircle at the base of the J. That's about the right size for the nerves that I'm going to be working with, the buccal nerves. And a reference point that I sometimes like to use is a staple, which happens to be about the right size. Okay, here I have a staple for reference. It's a little smaller than a millimeter in diameter. What I'm going to do is shape a hook such that it could wrap nicely around the staple. Now I want that hook to be at the base of the glue. So both of these wires are actually considerably longer than they need to be. I'm going to cut them to about this length and remove the enamel again. So that's a length of about 3 millimeters. Now what I want to do for one of these wires is scrape away a little bit of enamel at the end only, and that's going to be my reference wire. And for the other, I want to scrape away all of the enamel all the way down to the glue, or pretty close to it. That one's going to be my hook. So let's try scraping away the enamel from just the end of this left wire. And there I can see it flaking off immediately. That should be sufficient for a reference wire. I want to bend this out of the way backwards towards the glue. Alright, and now I'm going to attempt to remove all of the enamel from this other wire. And again, you can see the color difference. Here, it's still a bit goldish, whereas here it's just silver in color. Okay, that's nearly all of it, so I think that's going to be good enough. I can pluck off these enamel flakes. And now I can shape this into a J shape or a hook with a curvature such that the staple could kind of fit inside of it. Alright, that's looking pretty good. You could imagine taking this staple and dropping it into this hook, and it'd be about the right size. The nerve is pretty similar to the staple, so that hook should be pretty good. I think the hook is a little long on the top here, so I'm going to clip that. It's nice to have some extra length so that when you're doing the nerve attachment, the nerve doesn't easily fall off of your hook. But if it's too long, then it's likely to snag on something. These are millimeter markers. As a final step, I need to check the continuity yet again, and I need to indicate on the tape which pin corresponds to the hook wire, which I'm going to mark with a plus sign, and which pin corresponds to the reference wire, which I'm going to mark with a minus sign. So first the hook. One. There it is. And let's check for a short. Yeah, nothing. And then my reference wire should be on the right. Indeed, but not on the left. Okay, so the left pin should be marked with a plus because it corresponds to the hook, and the right should be marked with a minus, like that. I'm going to flip the tape over and do the same on the other side. Of course, making sure that I flip the signs so that they still correspond to the correct pins. And there you have it. One fully ready hook electrode. Now I want to prepare my hook electrode for attachment to a nerve. I have a mounting device, which is just a simple alligator clip without teeth so that it doesn't damage the electrode, attached to a stick, connected to a manipulator. I have it already set up over here, and this allows me to hold the electrode still as I position it in place over a nerve. Here you can see I have the hook electrode being held by the alligator clip at the end of the tool. When setting up to attach a hook electrode to a nerve, you can position the electrode in any orientation. And so that means that the electrode itself could be rotated such that the hook is easily visible, as it is here, or it could be hiding behind the glue of the electrode or in some other direction. It's important that you worry about your hook orientation at this early stage so that when it's finally time to place the nerve on the hook, it's very easy to do. It's also important to make sure that your reference wire is clearly visible so that you won't cover it in glue accidentally in a later step. For now, I'm just going to use the manipulator to shift the hook electrode out of the way. I have an isolated buccal mass here in a petri dish ready to go. You can see the buccal ganglia right here, as well as buccal nerves 1, 2, and 3. And today I'm going to attach a hook electrode to buccal nerve 2. So the next step is to use the manipulator to position my hook very near the nerve where I want to do the attachment. Next, I just need to lift up the nerve and place it on the hook. For that, you can use any sort of hooked tool. It's best not to use forceps to pick up the nerve because there's a risk of pinching it. If you're careful, that may be okay, but I prefer to use my bent forceps. Now I just drape the nerve over the hook, just like that. Now from this moment on, it's very important that the buccal mass and the petri dish that it's in doesn't move relative to my stationary manipulator and hook electrode. So here I have sticky tack that's being used in order to keep the petri dish from sliding around. I have another set of sticky tack down here holding this larger platform in place as well. The goal now is to encapsulate all of the exposed stainless steel wire of the hook, as well as the nerve where it's touching, in superglue. Superglue sets when it's exposed to water, so first we'll need to dry the nerve. And in this case it also means I need to elevate it above the water line so that it can be dried. I'm going to use the manipulator just to lift the hook. Water is clinging to the underside of the nerve by a surface tension. So what I can do is use a Kim wipe and grab the corner of it and twist it in my fingers to create a very precise drying implement. And then go in and touch that area of the nerve, and the water that was under the nerve was sucked away, and now you can see that the nerve is no longer trying to collapse on itself. Instead, it's suspended in the air. I'm going to do some additional dabbing just to make sure that there's no excess water anywhere. At this point, I have an option. I could make my hook shorter overall. You can see here that there is a segment of the hook wire that extends below the silicone glue down to the nerve. And that's a bit lengthy. I'm going to ultimately need to cover all of the hook in superglue, and it's best to do that all the way up to the silicone glue to give it some structural support. Because this wire is so long, I'll need to use a lot of glue. I prefer to use less. Using less means that it's more likely to dry completely and not accidentally come in contact while still wet with other tissues. So to deal with this, I'm going to use 2 forceps and readjust the shape of my hook, the J-shaped hook, so that the bend is further up. That's a little better. Now there will be less length of wire between the nerve and the silicone glue that will need to be covered with superglue. It's best not to leave the nerve in the air for too long, so I'm actually going to re-wet it right now so that it doesn't dry out. Alright, now I'm ready to try again. I'm going to elevate the nerve a bit more, go in with my Kim wipe, and dab away the water. So now to apply the first bit of superglue. This is going to be done in multiple layers in order to ensure that it dries fully and evenly down to its core. I'm going to use this very small insect pin in order to apply a very small amount of glue. So I'll start by squeezing out a very small amount of glue, much smaller than you'd think, and applying it to the tip of this pin. Under the microscope, it'll look like much more. And for this very first application, I'm just going to apply a very minute amount to the side of the hook. On the underside, it's not nearly sufficient to cover it. My goal right now is just to bind these two together, the nerve and the hook, so that there's no chance of movement causing it to slip from where it needs to be. So to set the glue, I just need to suck up a little water and spritz it. If I do this very gently, I can avoid blasting the glue off of where I've placed it. Alright, that should be set. So now I'm going to do a second round of glue, and I need to, again, dry the area where the glue will be applied. And this time I'm going to be a little more thorough with covering the area of the wire that is near the nerve. So I'm not going to do everything yet. Alright, there's a second coat of glue. It's still wet, so I'm going to set it by splashing it with some water. And again, we repeat. Dry the nerve. Now, this time I am actually going to do something a little different. I still need to coat this section of the hook on the right, between where the nerve is and the silicone glue. However, the end of the hook, the part that's sticking out here to the left, I don't need that anymore. It's not doing anything for me. Instead, it's just creating a problem because it needs to be completely covered in glue. Rather than slathering a ton of glue on there, I'm going to go in with scissors and clip off some of this excess wire. Great. Now, using a third very thin coat of glue, I'm going to make sure that I cover the spot where that wire just was and hit the wire above the nerve all the way up to the silicone glue. Sometimes you apply a little more than you intended, so you can go back with a dry pen to brush away the excess or move it around. Okay, that is pretty good. I might feel like I haven't done it 100% yet, so I think I'm going to go in after this wetting a fourth time, just to be sure that this area of the nerve is electrically isolated. I'm going to go in again, and this time I'm going to focus on areas I think I might have missed. The underside of the nerve and the section of wire above the nerve. It's essential that this is completely covered, but the less you use, the better it is for the sake of preventing problems down the road, such as a large mass of glue not fully setting, and then when it comes into contact with muscle, it adheres to it, or it adheres to other electrodes. Alright, I'm happy with that. My hook is completely encased in glue, and importantly, the reference wire is not. So you can see here on the right, the silvery bit that is the scraped away portion of the reference wire. Critically, the rest of the reference wire is still covered in enamel all the way up to the silicone glue. If the reference wire's enamel had been scraped away much further up, to the point that there was exposed stainless steel inside of my superglue encasement, there is the potential for a short, where electricity can pass directly from the hook to the reference wire locally without passing through the amplifier and the digitizer and letting the computer read the signals. So this can lead to a loss of signal. Now that the glue is done, I can release the tension that I placed on the nerve by lowering it. And now I want to carefully remove my electrode from the electrode holder. Rewetting the buccal mass periodically so it doesn't dry out is always a good idea. Alright, there we have it. One hook electrode attached to one nerve, ready for recording.